Hey everyone, welcome to lesson number 6. We're going to look at solving quadratic inequalities in one variable by case analysis. All right, so if we look at this first example, we're given the quadratic inequality x squared plus 2x minus 8 is greater than 0, and x squared plus 2x minus 8 is less than 0. So it's actually the same. If we were to make this an equation, it would be the same equation, but we have two different scenarios. For the inequality, we have it when when y is greater than 0, and when y is less than 0. And so the graph of the function use equation is, again, x squared plus 2x minus 8 is shown. We're given the y-intercepts, and we can find those even by factoring it, the x-intercepts, right? And our x-intercepts, we have our negative 4 and positive 2, and then the x-coordinates of the points are given on the x-axis here and here. And so if we were to find out what the solution is for each of these inequalities, it's going to be a little bit different. But if we look at class example 1, we want to determine the solution to the inequality x squared plus 2x minus 8 is greater than 0. So when this is greater than 0. So if we were to think of it as an equation, as is highlighted here, y equals x squared plus 2x minus 8, 0, or I should rearrange it like this. This upper portion would represent when y is greater than 0. Alright, so when y is greater than 0, my values of y would be any point on the line that is greater than 0, of course. And so in this scenario, I'm going to have two values of x. So x has to be greater than less than any point below negative 4. And I'd have another solution where x has to be greater than any point above 2. So again, x has to be less than negative 4 in order to be on this line, and x has to be greater than positive 2 to be on this side of the line. If we were to look at the solution to the inequality x squared plus 2x minus 8 is less than 0, so just the opposite solution, where our values of y are less than 0, then that would give me every point down here. So if we're talking about our solution in terms of x, then x has to be greater than negative 4, but it has to be less than 2. So for any point to be valid on this line, it has to be between negative 4 and 2. So these solutions can also be represented on a number line. So down here, this would be representative of x squared plus 2x minus 8 is greater than 0. And then the second number line, so this is my first scenario. My second scenario was x squared plus 2x minus 8 is less than 0. Is going to be represented by this second number line, where my values of x over here can either be less than negative 4 or greater than 2. But for x squared plus 2x minus 8 to be less than 0, my only values of x can be between negative 4 and positive 2. Alright, so we can find those different scenarios for a case analysis just by looking at the graph. But sometimes we're not able to do that because, I don't know, sometimes we're not given enough information. Other times we're just given an equation, or if we're just given an equation and we want to find out algebraically, we have to use a different scenario. That being said, we're going to use the same scenario we did last time in order to solve this next problem. So I use the graph of the function for class example number 2 of f of x equals 12 plus 4x minus x squared to solve the inequality 12 plus 4x minus x squared is greater than or equal to 0. Now, when we're tackling these types of problems, the first thing we can do is factor this. So if I were to factor this, it's kind of reversed. So negative x squared tells me that I'm going to have a negative x and a positive x here. And if I factor what multiplies to give me 12, but adds to give me 4. I got -6 and 2. Alright, so I know now that my values of x are going to come from my my x-intercept, and if I rearrange this, that's going to be -2 here and +6 over here. We can also just graph that, and if I graph that, 12 plus 4x minus x squared, I'll get a graph that looks something like that. I'll zoom out a little bit, or sorry, zoom out, that's my standard. So zoom out, and I'm going to have a graph that looks something like that. And so we can just go ahead and graph our rough outline of our function. So this is, the graph that we've drawn is the graph for the equation of 12 plus 4x minus x squared. We want to show the equation when it's this inequality. So remember, we have y greater than 0 and we have y less than 0. And if it's this inequality, less than or equal to and greater than or equal to. So we're looking for a particular solution region. We're looking for a solution that would give me something greater when y is greater than or equal to 0. So we're actually looking for everything above my 0. So if I were to highlight my solutions for this particular inequality, we're looking for these ones here. Alright, so if that's what I'm looking for, then my values of x have to be greater than -2 and less than or equal to 6. So x has to be greater than or equal to -2, but less than or equal to +6. On a number line, we're going to use our closed dots for -2 and +6, and we're going to shade in between. Those are my values of x, my permissible values of x. And then we're going to state the solution for the inequality 12 plus 4x minus x squared. And our solution is actually right here. So I got two solutions. X can either be less than or equal to -2, or x can be greater than 6. Now the solutions, sorry, that's a little bit different, but my solutions are going to come from solving my my zeros and coming up with my values of x. So if I were to plug these in down here and rearrange in order to set it equal to 0, this is where I would get these values from. So just in case you're wondering why the signs are different. All right, now let's look at investigating an algebraic solution to a quadratic inequality. Now, I'll let you go through this example yourselves. All it is some guy is wondering how he can solve the previous example, so class example number 1, which was x squared plus 2x minus 8 is greater than 0, without drawing a graph. So he just wants to solve it algebraically. And if we look at his, I'll quickly go through it, but if we look at his method of solving, first thing he does is he factors the inequality, and then he sets both of them equal or greater to 0. And then he solves by isolating his x. So he gets x is greater than -4 and x is greater than 2. And since x has to be both greater than -4 and greater than 2, he concluded that the only valid solution was x is greater than 2. It makes this first solution kind of irrelevant, because if x is greater than 2, that means x is greater than -4. So it doesn't make sense to mention x has to be greater than -4, since that's kind of, it's assumed if x is greater than 2 already. So there's another case that Colin did not consider, and so if the thing that Colin does not consider is if both quantities, x plus 4 and x minus 2, are negative, then the product can also be positive up here. Right, so if these are negative products, then he can't make that assumption. So determine the complete solution to the inequality. So the complete solution is if I look at the other scenario where x plus 4 is less than 0 and x minus 2 is less than 0, in which case if I rearrange, then x is going to be less than negative 4, and x is going to be less than 2. And so if this is the case, then it can be either or. X can be less than negative 4 and x can be less than 2. So sorry if this is going, if I'm rushing through this. I'm just trying to get through this so this video is nice and short for you. So if we solve the inequality x squared minus x minus 20 is less than or equal to 0 by an algebraic process, similar to the investigation on the previous page, remember the first thing we got to do is start by factoring this. So if I were to factor this, I have my values of x, and what multiplies to give me 20 but adds to give me negative 1. Negative 20 and negative 1 would be positive 4 and negative 5. And that is less than or equal to 0. So if I rearrange that, then I have x plus 4 is less than or equal to 0. And I have x plus 5 is less than or equal to 0. That means x is going to be less than or equal to negative 4, and x is going to be less than or equal to negative 5. Or sorry, positive. That should be positive 5. Positive 5. Now, if I think about what that would look like as a solution, can x be less than negative 4 and less than negative 5? Well, yeah. The answer to that would be, or sorry, can x be less than negative or positive 5 and negative 4? Yes, it can be. And so right away, that would be a solution that could work. But if we look at the other scenario, or I could have x plus 4 is greater than or equal to 0, and x minus 5 is greater than or equal to 0. If I solve for this, x is going to be greater than or equal to negative 4, and x is going to be greater than or equal to positive 5. So we have to kind of think about which solutions are going to work. If I think about this scenario, x is greater than or equal to negative 4, and x is greater than 5. Or sorry, x is less than negative 4 and greater than negative 5. That wouldn't work as a solution. That would make it kind of irrelevant. So my solutions are x has to be less than negative 4, and x has to be, get rid of that one, x has to be greater than negative 4, and x has to be less than 5, positive 5. So these would be my solutions for this situation. My next process is the case analysis. And so with the case analysis, the method used in this investigation up here is when we have two different variations. So when the quadratic inequality is greater than or equal to 0, then in the factored form, this results in two factors whose product is positive. And so we have two cases to consider. Both factors are positive and both factors are negative. If I have this situation going on, then if the factored form of the inequality results in two factors whose product is negative, there are two cases to consider. The first factor is positive and the second factor is negative. Or case 2, the first factor is negative and the second factor is positive. So we're going to look in class at this example here. All right, so we're going to look in class at how we would tackle this problem using case analysis. In class.